So sorry I cut that last video short. Someone was trying to get into the room when I'm wanting peace and quiet, and that's probably what the banging noise was that you heard at the end of the last video. So I finished off at here with this quadratic. Now you can either use quadratic formula, you can look to factorize, or you can even use the GDC calculator, where I've entered the function 2x squared plus 5x minus 33, and I've found the zeros here. Now, using a bit of common sense, I'm only going to take the positive number, because if I was to enter negative 5.5 into here, I'm going to get a negative length, and you can't have a negative length. Another way you could solve it in the calculator using GDC is menu algebra, solve polynomial tools, find the roots of the polynomial, and then I would put in that 2 is that one, 5 is that one, and negative 33 is that one. And there you can see it's negative 11 over 2, which is in 3. Negative 11 over 2 is negative 5.5 and 3. You can see the fraction to decimal. So there's a few ways. If you wanted to factorize it, you would multiply 2 and negative 33, which give you negative 66. What multiplies to make negative 66, but also adds to make 5. That would be 11 and negative 6. So you could factorize the quadratic and you would get the same answer there. Okay, now 11 is a very, very tricky one. I've been brainstorming this one and having a look, and I wouldn't even bog yourself down with this one, to be honest. If you really want me to do the solution of this one, come and speak to me, but there's nothing like this going to be in your assessment. Any proofs and things like that. It's quite a complex question. You need to know rules of angles and parallelograms. So for question 11, I'm going to rule that one out. Okay, if you want me to go over it with you one-to-one, I will, but I want to push on with the other questions. So on to question 12, which takes us back to the kind of questions that we'll get in the exam possibly. Question 12 gives you no triangle, just gives you some information. AB is equal to 7, AC is equal to 9, the area is equal to 20. So what are the two possible of A? So if I was to just draw a triangle, then AB would be here, AC might be here, but longer, 9, 7, I don't know the angle at A, that's what I'm trying to find, and then it's telling me that the area is equal to 20. So straight away, area is equal to a half, and then times 7 times 9 times sine A. So that's B and that's C. So a half, in this case, is BC sine A. Not to get confused, this is area, not A. Right, it tells me the area is 20, so I'm going to substitute it in. A half times 7 times 9 times sine A. So it's just all about rearranging. Take the half to the other side, that gives you 40, and then divide by 63. So a half times 20 is 40. 7 times 9 is 63, take that down, 63 is equal to sine A. So then we end up just basically with simple trig ratio. So what is A equal to? A is equal to inverse sine of 40 over 63. Inverse sine 40 over 63. 39.4. to 3SF. Then it says, given A is obtuse, find BC. So this is the acute angle, because we don't know whether this is obtuse or acute. We've just calculated the acute angle. So to find the obtuse, a little bit of extra knowledge, obtuse is equal to 180 minus the acute angle. So that'd be 180 minus 39.4. So just cross-check your mental math. 140.6 degrees. So if this is the obtuse angle, then it's asking me to find the length BC this time. So I've got a new triangle because it's obtuse. So it's actually going to go something like that, where it's 7 and 9. The area is still the same, but this time the angle is within obtuse, and it's asking me to find BC. So it's cozy, and it's going to be cosine rule. So BC squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 times cos 140.6. So I've done this before with you, how I type it in. I open up the square root, and then I do 7 squared plus 9 squared minus bracket 2 times 7 times 9 times cos 140.6. And that gives me 15.1 to 3 significant figures. And the units were indeed in centimetres. So that's 12 answered. Now on to question 13, where I have a car park apparently, and I've got a flagpole, bit of a flagpole. It tries to confuse you because it's got a 3D shape and a 2D shape. You actually don't even need the flagpole triangle till near the end. So all you're really focusing on is the 2D triangle at the moment. And it says find the angle ABC. Well, ABC represents this angle in here. And it's told me that AB is 90 and AC is 65. And the angle ACB is 68. So looking at that, it's going to be sine rule because I've got opposites. So it's 65 over sine B is equal to 90 over sine 68. So I actually normally write the angle on the top, but you might write it this way, then flip it. But anyway, what you end up with, sine B is going to equal 65 times sine 68 over 90. So B is equal to inverse sine of all of that. So put that in over here. Inverse sine, fraction 65 times sine 68 over 90. So that's 42. That's even to 3 significant figures, and it is measured in meters. Sorry, this is an angle, so it's degrees. So that's 42 degrees. Okay, then next one says find the area ABC. So to find the area, I can use a couple of methods. I could find this side and then use that angle and use that angle and use them, or I'm going to use the sides that I've already got. I've got this angle, I've got this angle, so I can now find the angle at A. So first of all, find the angle BAC, which is equal to 180 minus 68 minus 42. So that's going to be 110, so that leaves me 70 degrees there. So now I've just worked out that angle, which is 70. I just do area is equal to half times 90 times 65 times sine 70. So what does that leave me with? Half times 90 times 65. So it gives me an area of 2,748.6 meters squared. So a pretty large area for a car park. Now on to part C. It's now asking me to find BM. So M is the midpoint of AC, according to the question. And I want the length BM. So I cannot assume anything here. I can't assume that it's a right angled triangle, etc., etc. I do know that that's 70, and I can use that, but I don't know this angle. But if M is the midpoint, does that bisect this angle in two? Or I know this. So if M is the midpoint and this is 65, then 65 divided by 2, that means that AM is equal to 65 divided by 2, which is 32.5 meters. So this from here to here. So I'm just going to sketch out the little triangle I have. I'm not going to assume anything, so B to A. And then I've got A to M, which is 62.5. I know what that's 90. I know what that's 70. So it's cosine rule. So I have an angle cosi between two sides. So BM squared is equal to 90 squared plus 62.5 squared minus bracket 2 times 90 times 62.5 times cos 70. So pop it all into favourite calc for trig. Square root 90 squared plus 62.5 squared minus bracket 2 times 90 times 62.5 times cos 70, which gives me 90.3 to 3 significant figures meters. So that gives me the length of BM. Now, on to D, where it starts to talk about the flagpole. So it says a flagpole was put up in one corner with base H. Doesn't tell me the height of the flagpole. We've got the angle of elevation, which is 55.3. So here is M. This whole angle here is 55.3. Now, mathematics tells you that if H is the midpoint, then that therefore bisects that angle. So surely it can't be as simple as 55.3 divided by 2 to get the answer. 55.3 divided by 2 is equal to 27.65. So the angle of elevation up to the flagpole is going to be 27.65. because it's the last question, I always think it might be a bit harder, but if it's that easy. Now, I could try and go about it the long way and try and prove it, because I know BM is 90.3. I know this whole angle is 55.3, so I could find the height of FB. So let's just do that. FB is equal to, well, it would be opposite and adjacent, so it would be tan 53. So it would be 90.3 times tan 55.3. So 90.3 times tan 55.3. Flagpole's 130.4 meters. Interesting. So the flagpole's pretty high. Bigger than the car park if it falls down. Now if I divide that by 2, that's going to be HB. So HB up off the ground is equal to 130.4 divided by 2, which gives me 65.2 meters. So this is 65.2. So all I'm doing is verifying that it's bisected. So I've now got an opposite and adjacent. So let's just check that this all links together. So if I wanted H at that angle B, which is the angle of elevation, that angle is opposite adjacent, so it's going to be tan, I'm going to call it A for angle, is equal to opposite 65.2 divided by 90.3. So A is equal to inverse tan of all of that. So inverse tan of 65.2 over 90.3. And it gives me a different answer. Interesting, 35.8 degrees. So that's why you cannot assume that it cuts the angle in half. By doing some mathematics, I've actually shown that it's the angle of elevation is much higher, and because it's part D, I thought by halving it, it's not going to be as simple as that. So let me just run through that and make sure that all I've done is correct, because the angle of elevation up to F was 55.3. I knew that that was 90.3 from the previous question. As long as that's correct. Then I wanted the opposite and I had an adjacent. So tan 55.3 is equal to FB over 90.3, so that's why I times, which gave me this. Then I divided it by 2 because it's the midpoint, so that's got to be half. And then I did opposite over adjacent to find tan, and they gave me that. So happy to read your comments if you disagree, or come speak to me in class.